Hello friends, welcome to the today's online lecture. Today's topic for the discussion we'll be discussing some of the numericals based on the Newton's laws of motion. So we will try to cover two numericals within the time period of our today's lecture. So we'll start with the first problem. I had written the first problem. We'll try to understand the problem and then we will try to find out what is given and what is we have to calculate in the given problem. So let us start with the first problem. The problem first of all we will see the problem. Two blocks of mass M1 equal to 10 kg and M2 equal to 20 kg are tied together by a light string and are placed on frictionless horizontal surface. So within this statement, first of all we will try to write down the what is given. So given data. So two blocks are there whose mass is 10 kg and 20 kg. M1 is equal to 10 kg and M2 is equal to 20 kg. These two things are given. Okay, and these two blocks are tied together by a light string. So we have to focus on this word as well, light string, and they are placed on a frictionless horizontal surface. Okay, so in this problem, force due to the friction it will be 0. So we will be using that as well. It has been this arrangement has been shown in this figure. When M1 is pulled by a force F, see this force, it is acting on the block M1, is pulled by the force F, and acceleration of 10 meters per second is produced in both the blocks. So block M1 and block M2 both are accelerated with an acceleration of 10 meters per second. So acceleration it is given 10 meters per second square is produced in the both block. Calculate the force and the tension in the string. So we have to calculate the force and tension in the string. So T is equal to question mass. So these two things it has been asked to calculate us. Now let us start the solving this problem. So first of all we will try to calculate the force. Before that let me tell you one thing. As these two blocks are connected by a light string and both blocks are accelerated with the same acceleration, it means that there is no as such role is there for this light string. So this is a lightless, or we can say weightless string it is there. So we can assume in this problem this block M1 and this block M2, they are not separated but they are a combined system with mass M1 and M2. So what we will write, the blocks are tied together with light string and both have same acceleration. So block M1 and M2 can be considered as single system of mass M1 plus M2. Now here in this case, mass of the block M1 it is 10 kilogram and mass of the block M2 it is 20 kilograms. So 10 plus 20, this is equal to 30 kilograms. So the mass of the combined system it is 30 kilograms. Now we will apply the Newton's first law of motion to this system. So now this system it is a combined system. Now this system I am talking about, this is a total system of mass M1 plus and M1 plus M2, and force is acting on this block, it is F, and that is accelerated with an acceleration 10 meters per second. So from Newton's law, you can write from Newton's law, force is equal to mass into acceleration. In our case, mass of the system is m1 plus m2. So m1 plus m2 is into acceleration, which is 10. Okay. Now we have to find out the force. So we will write it over here. F is equal to, therefore F is equal to m1 plus m2 is 30 into acceleration of the body is 10 meters per second square. So 10 into 30 into 10, that will be 300, and force in SI unit is measured in terms of Newton. So it gives the answer to our first question, calculate the force. Now we have to go to the next problem, that is tension. It has been asked to calculate. Now we have to calculate the tension. Now in order to calculate the tension, I'll drop this, then we will go to the second part of the problem. Okay. Okay. Now this was part A. Now we will go to the part B. Okay. Now see, we have to calculate the tension between the string, that is T is equal to question mark. So in order to calculate the tension in the string, what we will do, we will make a free body diagram for the block M1. Now just imagine this. Let us say this is a block. Let us say this is a block whose mass is M1. Okay, and on this side, a force which is acting on the block, it is F. So let us show the force in this direction like this, and on this direction it is the tension which is acting in this direction. So let us call this as a tension T. In addition to this, we know that this block is resting on a frictionless surface and it is having a mass M1. So due to this, on this block, the force due to gravity, it is acting, which is nothing but the weight of the block, which is M1g. As this block is exerting an action on the ground horizontal surface, the surface will also exert a reaction on that, which will be opposite in direction. So it has a normal reaction in vertical direction. Okay. Now we have to calculate. See, one more thing which I want to show you is that as the force is applied in this direction, the block is accelerated towards this direction. In this direction, block is accelerated. There is no motion in vertical or downward direction. So this normal reaction and this weight, they will be cancelling each other. So there is no resultant motion along the y direction. If I say that this is my x-axis and this is my y-axis, then there is no motion along the y-axis. There is motion only along the x-axis. Okay. Now we will first of all try to calculate the equation of motion applying Newton's second law according to Newton's laws. According to Newton's law. Now, what is Newton's law? Newton's law tells us force is equal to mass into acceleration. So force is equal to mass into acceleration. Mass into acceleration. This is the simple statement of Newton's second law of motion. Okay. Now here in this case we have to calculate what is the force which is acting on the block M1, because this free body diagram I have shown for the block of mass M1. So the force on the block M1, as I have already told you, there is no force in vertical upward and downward direction, because this N will be cancelled by this M1g, because their action and reaction, they are equal and opposite in sense. So as they are in opposite direction, so they will be going to cancel each other. So there will be, as the block is accelerated only along the horizontal direction, which is the x-axis, so I will write the mass of the block, which is M1. So it is M1, and the acceleration of the block, which we have already calculated, which was already given, that is A. So it is M1 into A. Now what is the force acting on this block M1? It is F minus T, because the block is accelerating in this direction, so it is F minus T. It is the net force which is acting on this block because the block is accelerating in this direction. So this is F bar minus T bar, and this is M1 A bar. Okay, we have calculated the force which is 300 Newton. Or first of all, because we need to calculate the tension, I will transfer all the quantities on the other side and will keep tension on this side. So if I transfer this minus T on that side, it will become plus T, and this will become M1 A bar. This will be M1 A bar. On this side I will have F bar. So what I will do, now I will just consider the magnitude. I will no need to write this vector components. Okay, now write this equation. T is equal to, if I transfer this M1A on this side, it will become F minus M1A. So this is equal to F minus M1A. So what is F? F we have already calculated, which is 300 Newton, minus mass of the first block, it is 10 kilogram. So it is 10, and acceleration of the each block, it is 10. So if you try to calculate this, you will get this value like this. Okay, so therefore T is equal to 300 minus 10 into 10, it will be 100. So 300 minus 100, it will become 200. So tension in the string, it is 200 Newton. So this is your second answer. Okay, I hope you can do these simple calculations and you have understood this. Okay, now you just have to simply write the two statements over here. The first thing what you have to write is that the force acting on the block, it is 300 Newton, which we had calculated there, and the second statement is the tension in the string is 200 Newton. Okay, now we will go to the next problem. Problem number 2. First of all, we will note down the problem. Problem number 2. Figure shows two masses M1 and M2. Two masses M1 and M2. Two masses M1 and M2 connected by a thread. Connected by a thread. Connected by a thread. Full stop. If the kinetic friction between M1 and the table is M1 and table is 19.6 Newton. 19.6 Newton. Full stop. Find the acceleration of the system. Find the acceleration of the system. Find the acceleration of the system. First of all, we will just draw the picture which is given there. Okay, so let us say this is an horizontal surface, and to this horizontal surface one pulley it is there. Okay, and there are two blocks. One block which is going over this pulley. Okay, let us say this is a pulley, and string is going like this, okay, and there is another block which is attached at this point, okay, and there is another block which is attached at this point, okay. So, and this is a horizontal surface, okay. The force F1 is applied in this direction. The block mass of this block is M1. The mass of this block is M2. The mass of this block is M2, which is 3 kg. Okay, and tension is acting in this string in this direction, like this, and in this tension it is acting in this direction. Okay, and the system is accelerated in this direction. Okay, and the mass of this one is 6 kg. Mass of this block is 6 kg. We will do, we'll go through the first of all, we'll go through the problem, and then we will try to find out what has been asked in the problem. Now see, figure shows two masses M1 and M2 connected by a thread. Now see, here it is the block of whose mass is M1, which is 6 kg, it is given. There is a second block whose mass is M2, which is 3 kg. So we will write down the given data. M1 is equal to 6 kg, M2 is equal to 3 kg. M2 is equal to 3 kg, and the kinetic friction between the M1 and table, it is given 19.6 Newton. Okay, so that is given also. So the kinetic friction, it has been written over here, that is force due to the friction, it is F1, which is 19.6 Newton. 19.6 Newton. So that is also given. And find the acceleration of the system means we have to find out A is equal to question mark, means this, the acceleration which is in this direction, that we have to find out. Now, though its name it is not given in the problem, that F1 is a frictional force, but here we are assuming that F1 is a frictional force. Now what we will do, in order to calculate the acceleration in the system, we have to make a free body diagram for the block whose mass is M1 and the block whose mass is M2. So first of all, what we will do, we will try to draw a free body diagram for the block M1 whose mass is M1. So let us say that this is my x-axis. Let us say that this is my x-axis, and let us say this as my y-axis. Okay. So this is my y-axis. Okay. Similarly, I have to make a free body diagram for the block M2 as well. So what I'll do, I'll say that this is my x-axis and this is my y-axis, similar to this one. So let us say this is y-axis, this is x-axis. Okay. Now, so this is x-axis. Now I'll put in the first cave, I'll try to find out the free body diagram for the block M1 whose mass is 6 kg. Let us say that this is the center origin of the frame where I have kept this block whose mass is M1. Okay. So this is the point where I have kept this block whose mass is M1. Okay. Now the forces which are acting on this block M1. Now we know that as the block is having a mass M1, so there will be a force in the downward direction, which is nothing but the weight of the block. So M1G is the force due to the acceleration due to gravity. Now, as the block is exerting the action on the horizontal surface, there will be a normal reaction which is exerted by the horizontal surface on the block. So, which is normal reaction. So, let us write it is as a N. Okay. So, force is in this downward direction. This is in downward direction. This is in upward direction. In addition to this, along the x direction, along this direction, the tension is acting on this block. So, let us say that there is a tension which is in this direction. So tension is in this direction, and in addition to this, the frictional force which is in the backward direction, because always we know that whenever there is a motion, friction is always in opposite direction. So as the block is accelerating in this direction along the positive x direction, the retardation of frictional force is in the reverse direction. So it is F1 bar which is in downward direction. So this is F1 bar which is in this direction. So from this one we will get the one equation. Similarly, now we will try to draw a free body diagram for the second block whose mass is M2. Now consider this block. Let us say that this is the block whose mass is M2, which is placed at the origin O. So this is the second block whose mass is M2. This is the second block whose mass is M2. Now, as the block is having a mass M2, so force due to the gravity will be in downward direction. So I will just write it here. The gravitational force is in downward direction. It will go in this direction. And this block actually, it is not on the surface of, it is not on any surface. So there will not be any normal reaction, but this block is connected to the string. So due to this string, what happens? This string is under a tension. So this string will be exerting a tension on this block, so which is in upward direction. So this tension, it is in upward direction. Okay. So this is a free body diagram for the second block. Now what we will do? We will try to write the equation of motion for these two blocks by using the Newton's laws of motion. We will try to draw an equation of motion from this free body diagram. So for let us call this as an figure A. Let us call this as an figure B. Applying Newton's laws of motion. Applying Newton's laws of motions. Newton's law of motion to figure A and B. Figure A and B. Okay. So first of all, we will try to calculate the equation of motion for the object whose mass is m1 and then it is shown in figure A. Okay. So now see, what is the net force acting on this? We know the Newton's laws of motion. The force is equal to force is nothing but mass into acceleration. Force is equal to mass into acceleration. This we know. What is the mass of the first block? It is m1. So I will write it here over simply m1, and acceleration in the block it is a. So it is m1a is the mass into acceleration. But this block is kept at this point and the motion is in x direction. This weight and normal reaction, they will be in opposite direction, so they will be cancelling each other because there is no motion along a vertical direction. Now forces along the x-axis are nothing but that is a tension and this frictional force. So I will write it over here, T minus F1. T minus F1. So this is my first equation of motion. This is the first equation of motion which I have derived for the first figure A. Now similarly we will try to find out an equation of motion for the second figure B. So similarly, if I ask you to calculate, similarly the force is equal to mass into acceleration. Force is equal to mass into acceleration. So what is the mass of the second system? Which is m2. So it is m2 into. It is m2 into. Both blocks are connected by a string. If it is moving, accelerating in this direction, this block will accelerate in downward direction. So its acceleration will be again a. So it is again m2 into a. Okay. Now what is the force acting along the y direction on this block whose mass is m2? So what is the force? It is due to the gravity, which is weight of the box. It is m2g minus tension in the string, that is T. tension in the string, it is in upward direction, that as they are in opposite direction, that is why I have given a minus sign. Same is the case over here. This is in this direction, this is in this direction, so opposite direction, that is why I have given it in negative sign. Now see, let us call this as an equation number 2. Let us call this as an equation number 2. Now I will rub this figure, because now we have to simplify these equations in order to find out an acceleration. From this one we have to calculate this value of A. So it is just a simultaneous equations with variable T, A. So we can eliminate one variable and we will get the value of second one. So what we will write? Adding equation 1 and 2. Adding equation 1 and 2. Equation 1 and 2. So what is the equation number 1? T minus F1. So addition will be from LHS, LHS and RHS, RHS. So this LHS I will add with this LHS, which is M2G minus T is equal to RHS, RHS addition, that is M1A plus M2A. M1A plus M2A. Now this is plus T, this is minus T, these two will cancel each other, and here you will get M2G minus F1 is equal to, here acceleration you can take it common, so here it is M1 plus M2 into A. M1 plus M2 into A. From this one I can rewrite this equation as acceleration is equal to, I can rewrite this acceleration is equal to, if I write acceleration is equal to, acceleration, this M1 plus M2 is multiplied to this term. If I transfer on this side, it will get divided. So it is M2G minus F1 divided by M1 plus M2. Divided by M1 plus M2. So this is a value of acceleration. Now we have the values of M1, M2 and 4. So we can substitute in that equation. So what value of M2, it is 3 kg. So 3 into, okay, G, value of acceleration due to gravity, it is not given. We can substitute the value of acceleration due to gravity as 9.8. So 3 into 9.8 minus F1. F1 is 19.6. 19.6 divided by M1 plus M2. What is value of M1 plus M2? M1 is 6 kg, M2 is 3 kg. So it is 3 kg plus 6 kg plus 3 kg. So like this. This is the value 6 kg plus 3 kg. 6 plus 3 we will write it over here. Okay. This is equal to 3 into 9.8, it will come out to be 8 3s are 24, carry 2, 8 9 3s are 27 plus 2, 29. So it is 29.4 minus 19.6 divided by 6 plus 3, 9. So this, if you simplify this, this will come out to be 9.8 upon 9. And if you further do this division, you'll get, you'll come up with the answer which is 1.09, which is 1.09 meters per second. Even calculators are allowed in the exam. You can use the calculator as well. So A is equal to 1.09 meters per second. So you just have to write the simple line that the acceleration of the system is A equal to 1.09 meters per second. If the as in this problem only acceleration it has been asked to calculate, if the value of tension is also asked to calculate, if it is asked in the exam, what you have to do is that simply just take a value of acceleration, put it in the equation number 1, M1 value you know, F1 value you know, so it's easy, you can easily calculate the value of T. Even you can put the same values in the equation number 2 as well to get the value of the tension. Okay, I hope you can do this as an assignment, as an exercise problem for a homework. What you have to do is that you have to take the same problem and you just have to work out the value of tension in the string. With this, we will stop for the today's lecture. Thank you so much.